What up, John? This is Eli. I'm coming at you with the group project number 2. We had in our group me, Brandon, and Jessica, and we decided to do the investigating exponential growth using pennies. For this project, what we did is we had a cup, had 100 pennies, throw the pennies in the cup, shake it up, pour it out, and then we separate the heads and separate the tails, and for every pair of pennies that are tail side up, we add another penny to the pile. If there's an odd number of tails, we round down. Alright, so what they wanted to do is they wanted us to record all of our trials. We had 10 trials, and for each trial we had 15 rolls, and they wanted us to find the percent change between each trial and each roll, and create a scatter plot to show how they differ. So I wanted to show you, it's going to be kind of hard to see, but this is the statistics spreadsheets. We recorded everything. We found the averages between each roll, and then this is a scatter plot again. I apologize, but I can't flip the camera, so this is actually going up, not down, but it's well, I'm sorry about that. So the first question they asked us was, should the graph touch the x-axis? Why or why not? So we said no, it should never touch the x-axis because it will never touch 0, 0. When you're starting with 3, if you add 2 and subtract 1 every time, it will never get to 0, 0, so it will never touch the x-axis. Then what they asked us to do is to create a formula for our graph, so you could find how many pennies will be for any roll, 25, 50, 75. So for our equation, we did y equals the original amount, parentheses 1 plus the rate of increase, and then close the parentheses. The exponent will be blank for t, for how many rows you want to put up there. So for our c, our original amount will be 3. For our rate of increase, it will be 14.6%, and then we leave the t blank for however many rows you want to put up there. To find the average of increase, we took all of the rolls, we added them up, we divided it, and then we just found the increase. You can do this manually by calculator, but we found it to be easier in the spreadsheet since you can do it a lot faster. So what they wanted us to do after that is they wanted us to take our equation, and then they wanted us to find how many pennies there will be with 25 trials and how many pennies there will be with 50 trials. So took our equation, and then we put 25 in our t area, and then once we calculated it, we found 90.52 pennies, which it's impossible to get point something, so we rounded up that to 91, and then we put 50 in our t area, and the result was 2,731 pennies for that one. Alright, next they wanted us to find a exponential decay model. So how we did this is we did again 100 pennies, put them in a cup, shake it up, pour them on the table. This time, for every penny that was tails, we subtracted from the pile. No adding, no nothing. So what it asked us was, should the decay graph touch the x-axis? And we said yes, it should touch the x-axis. Even though there were some times that it didn't, most of the time it should. Because every roll, you're going to get tails, and then you're just going to keep subtracting, and then it will equal 0. But some of our results ended up having 2 or 1 at the end because we just couldn't get the tails. Most of the time it will touch the x-axis. So I want to show you, again, we have a separate sheet here on our spreadsheet to show you. Again, it will be a little confusing because you can't really see it, but this is the second one. And then our graph is down here. Now, this, unlike the other one, is actually going down, not up. It's going down. So, as you see for some of the trials we hit the 0, which is x-axis, and sometimes we don't. It really depends on, I guess, luck. I would say that. Can't really predict that. Alright, and so then they want us to take all of our statistics and make a equation for it. And we did that. Our equation was 100, since we started with 100 pennies, parentheses 1, and then we did minus because it's exponential decay, and our percentage of decreased was 26.93%. Then we closed out the parentheses and we put T on the top for whichever amount of rolls you want. They didn't ask us to find 25 or 50, so they just wanted the equation, so that's all we did for that. They did ask for the doubling time though, and to find this we used the approximate formula for doubling time and half-life. So our doubling time was 4.79, and the half-life for our decay model would be 2.59. I'm sorry, for the doubling time for our exponential model was 4.79, and for the decay model was 2.59. And then for our last question, they wanted us to create another equation, but this was A parentheses B and under KT. A equals our initial value, so it would be 3 pennies. We start off every trial with that, or we started it with 100 pennies with the decay model. So whichever model you want to use, it would be either 3 or 100. And then B stands for our rate that we are increasing or decaying. So it would be our average percent for difference, which was 14.6 for the exponential growth and 26.93 for the decay. And K stands for our amount of rolls every time. It will always change depending on what you are trying to look for, whether it's 25 or 50 like they had before, or you want something in between like 32 or something like that. Yeah, so that's all they asked for. That's the whole project. It was a little bit time consuming with the rolls. I didn't realize you had to do that many rolls in the trials, but the calculation part wasn't as hard as you would think it would be, especially with the spreadsheet. It made it a lot easier knowing what to do. So yeah, that's the project. I am sorry about the light. It's kind of awkward. My room setting is just like with the light in the middle. So and then with the graphs and everything, I'm sorry it won't let me flip the camera, so everything's kind of upside down, so I tried to kind of explain everything as best as possible. So I hope you like the project. We worked really good together. We just had, again, scheduling problems. You know, everybody works. You know, we're full-time students, stuff like that. So I just decided to take it upon myself to make a good presentation, and I really hope you liked it. Thanks.